So for those of you who were at the quantum computing talk yesterday, this is kind of an extension of it. It's an Ask Me Anything session. I'm going to try to prime the pump for you conceptually, walk through kind of a credentials deck, and then also walk through just a couple of experiments, 3, just to kind of give you a feel of where quantum can start. And then as we begin to ask questions, we bifurcated the world into producers and consumers yesterday, where producers make the tech, consumers use the tech. Most of the conversation should focus around the consumer-oriented. How do you use this technology? And you're all consumers. So as a quick credentialing, you don't need to know about me, but I do sit on technology leadership side of the house, Academy of Technology. I'm a mentor on the inventor, so patents and things like that. Mentors for artificial intelligence and quantum computing, cognitive computing as well as that. Number of certificates, wrote the foreword for that book right there. Wrote a government recommendation for one of our colleagues who's in the quantum chemistry business, was a contributor to Capgemini's report. Harrisburg University is using some of our materials as well on the educational side, because when you bifurcate things into producers and consumers, there's just nothing on the consumer side. Spoke at a lot of conferences, started up a Minnesota meetup group prior to COVID, spoken at a lot of conferences as well, did some podcasts, things like that, speaking here, of course. Part of the Quantum Strategy Institute, which is one of the institutes I'm going to give a plug to, because they're fusing the business side with quantum, and there's a lot of interesting conversations of how the businesses and verticals across industries function there. So that's a very useful engagement to get into. It's been great on our side of the house. I've got a couple of patents, one in the polygenic risk scoring space with quantum, and another one in the systems biology space as well. So we're doing some work there. We've done some POCs where we've swapped out encryption patterns from the classical encryption patterns to quantum safe algorithms and built ways of testing that in-house. That has given us a platform to begin to do pressure testing across the enterprise in this space. And of course, this is how we bifurcate the world, right? They're the folks, the producers and the consumers. We're all consumers. And from an educational standpoint, there's almost nothing there for us. And that's a big deal. And it cuts down on the noise when you begin to look at what's happening in quantum space from that lens, because much of that's coming from the producer space right now. Been looking at this for the last 4 years or so. Optum Tech University is one of the organizations that we help. Optum teaches Optum. We've got a little organization there called the College of Artificial Intelligence, and then we're situated in there. Highly connected to the patent program. That's our commission for this. And we've done this on the wicked cheap, which is very helpful these days. Developed a 6 to 9 month training course. We've had all of those authors from Keeper to Frank to Robert Suter, Eric Johnson, all come in and talk to our group, as well as many of these corporations. We've gotten 2 cohorts through already, getting ready to start on the 3rd, so we've done this for a little while. And we're educating healthcare software engineers on how to use quantum. So these are areas that we can talk about. We've got a number of courses, a number of modules, 51 in our 6-month course. This is kind of how we begin to train software engineers in that quantum space. And the idea is, give me a good computer science guy, and I can put him through a process that will get them as well as they can be with the theoretical and experiential foundations to go ferret out patents in the organization. This is what we do. And they give them the best opportunity to do that. So that's kind of where we are. And the idea is to develop strong intuitive powers around that. And so we approach it using lots of different simulators, things like that. All right, so a couple of demos. So if you've never looked at quantum and the value of quantum, let's show you speed, parallelism, and search as quantum, is where the value is. And if you like puzzles, here's one of those. So you have 2 boxes. In one is a man-eating tiger, and the other one's a cute kitten. And at least there's 2 notes on both boxes, and those notes are either both true or both false. I mean, it's a standard digital puzzle. And you can create a digital logic circuit that you can run 4 times, and you're guaranteed to figure out where the kitten is and where the tiger is, right? 0, 0, 0, 1, 1, 0, and 1, 1, for those who remember your binary. But if I said you can only run that circuit once, now what are you going to do? Well, this is the quantum circuit that will allow you to do that. I will take that digital, one could take that digital solution and convert that into its quantum doppelganger. And when you take those two boxes and convert those to qubits and put them in superposition, now all of a sudden you run those four options at once, and you only have to run that circuit once, left to right, and you know exactly where the cute kitten is and where that man-eating tiger is not. So that's an example, a layman's example of quantum speed up. It's not because we do things better, faster, quicker. It's because we compute differently. I'll give you another example too. So if I gave you a deck of cards, you wanted to find the seven of hearts, it wouldn't be too hard. The input space is pretty small. But if that's 52 cards. But if I give you 52 million cards, anybody who's been in the computer science space realizes that, hey, that input size is going to change things. Well, let's say we had 52 million people in a room, and I wanted to find the one guy out there who's 7 feet tall, who's male, 7 feet tall, blonde-haired, blue-eyed, full of muscles, four things, right? Everybody stands up. All the women in the room sit down, so half the room is gone. All those guys who don't have blonde hair and blue eyes sit down. Most of the room's gone. All those guys who don't have blonde hair, blue eyes, and full of muscles sit down. So in four tries, within a constituent group of 52 million, I found the guy I'm looking for. That's how quantum does it. It does that search differently. The computational aspects of quantum is different. And so that's another thing that I wanted to kind of show you. And then lastly, oops. Yeah, okay. Well, lastly, I was going to show you parallelism, but we can talk through that. So that's all I want to do to prime the pump here. I'll leave it here. And then I wanted to open up the floor to questions. Keep in mind that I would like to move things more towards the consumer orientation of it. Like, what do we do as consumers? Not what are the big companies like IBM and all that going to do as creating the technology? And how can this help you? So that's kind of how I would like to frame this up, but I'm open for questions.
I just want to know, thanks. In terms of the pharma, like, do you have examples of pharma adapting this already and what has been done? So for example, I work in drug discovery, so I can totally see potential of screening faster, searching faster.
Yep.
But I would like to know some examples which have already been done that I can relate to, and also in terms of the economics of implementing this, say for an academic or non-profit organization, what is the cost involved, or is it available to only those who can afford, or yeah.
All right, so lots of questions to unpack from there. So every quantum conference I've been at, pharma has been a major player. So this is as opposed to healthcare, right? So if you, from a healthcare perspective, if you get the very last guy in line who's ever going to adopt quantum right now, and then you go a mile past that, that's healthcare, right? So we're in the back end of the adoption. Pharma, on the other hand, is at the front end of adoption. So they always put life sciences and healthcare together. I don't know why, but so most of the key initial use cases are going to come out from R&D and drug discovery on that. It's not going to be on the process and production line of the house just yet. It's going to be there. And so drug discovery, molecular modeling, the list just goes on and on. There's lots of use cases out there. And they have been major players at almost every quantum conference that we go to. Zapata and many of the other players out there in the pharma side are looking at this. The problem is that many of the tools that you would expect in a mature computational environment, like quantum IDE, quantum RAM, quantum operating system, abstract programming concepts just aren't there. Think of, anybody take assembler in college, grad school, right? You hated that. Have you recovered emotionally from that experience yet? This is worse than that. And so the folks who are trying to make solutions from that are literally in that space. It's a few steps back from assembler programming. We're actually placing, much like this, right? We're placing quantum circuits on a quantum circuit board to hopefully try to solve that difficult problem. And so the problems, and so those tools really aren't available. So the folks in pharma who are trying to do this have a very tough problem because they don't have the tools to work with, and they have only a few elite, highly trained academics and engineers who are capable of doing this at its current level of maturity, and that's where they are. So they're trying to fight that fight. They're really ahead of the curve. Now there's a couple things, like they've got to try to do things that will help them get into production, but then there are other folks in that space that need to move the organization along. Like there's this maturity curve of getting people, the whole organization further along in that quantum space. Some of that's been well trodden. So hopefully that begins to address some of those. There's a lot to unpack in your question. And if I miss anything, let me know. I'll try to give it a shot.
And in terms of the affordability,
So good question. So one of the learnings that we had from doing this for the last 4 years in a healthcare organization is that quantum is not a CapEx problem. It's not a capital expenditure problem. It's an OpEx problem. It's an operational expenditure problem, which makes it much cheaper. So there's two aspects of quantum that you want to look at. How do I do things with real hardware? And then how do I do things to learn? Doing things to learn is next to dirt cheap because you can get the simulators that can run on many different environments of many different stripe. Those are free. You can get them online. And many of the big vendors have simulators as well for various things. That's where you want to learn because you can inspect interim results. Like if you take a qubit and you spin it up in superposition, on real hardware, you can't inspect what those interim results are. But on simulators, they are functions of the mathematical ideal. And I can stop that calculation and look at some of those moving parts and begin to understand how things are processing, which are integral for understanding whether or not your algorithm works. But then you get to the hardware side. When you're done that, and you actually go to try to run that at scale on hardware, and now you can talk to AWS or IBM, many of those folks who have cloud offerings, and all of that is just operational costs. You don't have to have this big refrigerator in your basement. So it's affordable, and I think that's one of the big revelations, is you can do this stuff, and you should do this stuff. Hopefully that's helpful. One more point. That's on the R&D side. Now when you productionalize this, that's a different story. And many times you want to do projects that you don't have a real reason to do just because you need the knowledge of figuring out how to engineer that stuff. So one of the biggest challenges for quantum in healthcare organizations and across industries is how do I engage that quantum complexity in my current IT stack? And that's not a simple game because everybody's IT stack is different. So when you begin to productionalize something, and that's why you want to try to productionalize something as quickly as you can, even if you don't need it, because you're going to have engineering learnings from, how do I get an API out of AWS that does something like random number generation, and then get that into my organization. What are the engineering learnings from that? That's not intuitive obvious, and that's hard work. So hopefully that helps a little bit too. All right, sir.
Yeah. So you mentioned basically it's difficult to program that quantum logic, and it needs specialized people.
Mm-hmm.
I'm just wondering. I don't know much about quantum, just the basics. But isn't it possible eventually to create a standardized compiler that can go from digital logic to actually compile and convert it to quantum logic?
Sure, they do it now. That's happening now.
Okay, so then why it still need specialized people? I mean, any digital programmer can write it and then convert it.
Sorry, I'm going to draw a metaphor for you. Okay, did you ever use VMware?
Yeah.
Okay, so infrastructure by code. You write a bunch of code, and it creates infrastructure on the fly, and voila, automatically something happens. That's like these things, the higher level programming languages are like Python and many others, Bracket, and IBM's got their own Qiskit. Those tend to compile all those things down to signals that go in. Okay. At that stage, you're just using a programming logic and an abstract programming interface to still put circuits on a circuit board conceptually and solve the problem. So even though you have the higher level interface, you don't have higher level programming concepts available to you. You're still at the very lowest level doing this, and that's why it's so hard.
And can that be automated?
To an extent, but no, I don't. I think at the lowest level, when you look at the promoters and detractors of quantum, what that ends up being is it reduces significantly the kinds of problems that can be addressed with quantum. That's the other big, dirty little secret of quantum, is there's only so many things that can be addressed because of the lack of maturity, right? So the kinds of problems that can be addressed are either quantum friendly or quantum force friendly, or they're part of a classical problem that we can tear apart and then find those sub-problems that are either quantum friendly or force friendly. So that, until the current state of the art matures, all of the other capabilities that surround that you would expect to have, like quantum IDE, quantum RAM, quantum operating system, high-level algorithms, things like that, they're not even on the drawing. Well, they're on the drawing boards, but they're not being actively pushed out to the consumer level. And because of that, those enablers to get it quantum out of the lab and into the hands of folks like you and I to solve these kind of problems is just not there. Yep. Other questions?
Yesterday we spoke a little bit about there's kind of a steep learning curve. So you have to invest now in upskilling your organization for them to be able to capitalize on this. So I understand that's part of the conversation you have to take to the stakeholders at your company, or just if we're speaking on that quantum strategy consortium you're part of, whatever position you'd like to speak from. But I'm curious how you tactically identify use cases and sort of get the investment that is needed, and not even just the OpEx investment, but the time and resourcing from, let's say, R&D staff, if we take that use case, that would otherwise, they're at max capacity on their other projects. This is sort of something that is very much on the horizon and is years out from real life value. So I'm just curious what your best practices are.
Lots to unpack there. So let me see if I remember enough of that to unpack it all. Now, you're in pharma, and we're in healthcare. So when you talk to your executives, and pharma is very aggressive about reinvesting sales into R&D. So you're going to have a way more sympathetic audience than we ever will, because most of our executives will ask the simple question: what's the ROI? Or is there a threat out there in the wild that I need to deal with? So both of those are kind of important. I think you'll have an easier time than we do, and we had our own coping mechanisms, right? We did it on the wicked cheap. We never asked permission. We had a bunch of passionate guys do this on the side of their desk. I mean, I created my course. It took me 6 months to do it, and I'm still married, which is a very helpful thing. I think in your case, you can leverage both the carrot and the stick, right? Because the competition in the pharma space is ridiculously crazy. And so if there's an opportunity to get a leg up, do that. Also, in your case, from the pharma side of the house, like, everyone is doing that because it's a serious thing. And if you're lagging behind that, then you have entry barriers to guys who do that, who I don't think are going to share their learnings in a hyper-competitive space. The other side of the coin, though, is the security side, which helps. Oftentimes, if a new technology busts through the door because it has to, then your executives are forced to engage conceptually. Now, executives in any organization deal with concepts. They're never going to roll up their sleeves and get their fingers dirty writing code, at least not anymore. And the things that can be adopted are usually associated with the things that can be understood. And like in Optum, you can't swing a dead cat without hitting somebody that knows how to do Microsoft SQL. But it wasn't until recently where you had problems with people who understood the depth and gravity of AI. And that was just one standard deviation out. Quantum's at least two. And so there's this ability to communicate in a method that they value of what the risks are and the values, which I think in the pharma space is going to be a lot easier to sell than ours. On the security side, though, sometimes that helps you because there's an issue that busts through the door that says, you need to address me. And then they go, oh, well, what's your name? Well, my name is Quantum. And so NIST just came out and chose their first round of a number of candidate algorithms for quantum-resistant encryption services. That was a signal for us who've been watching that space that was a signal to the entire industry. Like, it's time to get going, guys. Like, we made our choices, and we're going to make more. And they've had their ups and downs from there. But that was a big signal. We went up to our CIO and said, hey, NIST is signaling to the rest of the organizations out in the industries, you need to get moving in this space, and here's why. That's helpful. You can generally bark that up the chain and go, you got to deal with this. This is this is not something you can kind of put under the table. And by the way, here's all the other stuff we can do as well. So sometimes those are useful strategies that we've employed, and they may work for you, but I don't think you'll have as hard of a sell as we did. All right, other questions? I think the mic is coming up.
Hi. So I attended your talk yesterday also, and you mentioned one of the drawbacks of quantum computing was security.
Mhm.
Could you touch more as to what the drawbacks in terms of security looks like in terms of quantum computing at this maturity and in the future?
All right, so the idea is, there's a couple of things that I can bring to light, right? The idea, general idea is the potential, the conceptual potential that RSA encryption as we know it can be based on Schur's algorithm to factor a large number could be at risk for quantum computers somewhere that could do that. So that's been debating, people are going up and down as to where it is and all that. But that's the main security concern. Now fast forward that, there's two threat vectors I want to throw out there. You always want to pay attention to your threat vectors. How probable is it that somebody could do that? Well, right now, quantum is in these big refrigerators in the basement. And there are cloud offerings, things like that. You can't really distribute that around the world too much until recently. Until Quantum Brilliance decided to make a 3-qubit quantum accelerator that's just about the same size of a GPU that you could stick in your computer. And it's done at room temperature. Now it's 3 qubits, so it's not going to break anything. However, it's the first time they used diamond nitrogen vacancies to do that, which is a unique kind of physical method of holding those kinds of qubits in certain ways. Even though it was a toy, that told us that somebody could do this at room temperature, and that means that the threat vector could spread globally. And so assuming that engineering can make things bigger, faster, smaller, and they could take those diamond nitrogen vacancies and figure out how to do that and do quantum at some scale globally, that expands the threat vector. That's a big deal. We took that to our senior leaders and said, hey, look at this. This wasn't conceptually viable. And this was just last year in September. I think September 27th, the article came out. Now here's the other thing. So that's one. So that shows the threat vector could expand quite a bit. A paper came out, and I have this. We spoke at QSI with the author of that said, if you have blockchain, and you have an envelope out there with a transaction, like if you're sitting there in blockchain, you're fine. But the moment you trade, if we have a quantum computer at 1,000 workable qubits, the theory suggests that that transactional aspect of that can be reverse engineered and the encryption can be broken. Now that's significant because that's modern day, and that's right now, and like Honeywell and IBM and many of those other guys are pushing that 1,000 qubit level. So once you hit that, they're like quantum or blockchain and all those kinds of things and crypto, it's all at risk when you trade. Now that changes the conversation too, because that's a real thing that you go, hey, it's happening right there, potentially. I got 1 minute remaining. Last question.
We kind of talked about it yesterday a little bit, but if you try to find the 7 of hearts and the 52 million deck of cards, medical imaging, we're technically kind of doing the same thing, finding the cancer in a stack of images. Mm-hmm. So if you had access to 1 billion images, what kind of questions would you ask, or is medical imaging low-hanging fruit for quantum?
I think it may be. Now, I'm not an expert in that space, but I do know that there have been meetups recently and other groups that have met recently that are talking about medical imaging with quantum, and maybe I can look that reference up and get it to you. And I thank all of you for giving me the opportunity to speak in front of you today. I will be hanging around all day. This is my last responsibility of the day, so I am game to chat with anybody at any point in time, before or after the conference or over coffee or beers, it doesn't matter. I'd like to help the constituency out any way I can. So thank you very much for the time here.